Alright, so we're going to try to do this, but the dog's wanting attention too. So, we're going to talk about our division properties, so our division rules. So, kind of like with the multiplication, why this works. So, 4 to the 5th would be 4 times 4 times 4 times 4 times 4. And we're dividing by 4 cubed. And here comes Daisy. Alright. So, when we divide, we can take anything that is the same on top and bottom. So, I can just, here we are dividing out our 3 4s from the top with our 3 4s from the bottom, and we're left with 4 times 4, which is 4 squared. So, that would be the same as taking 4 to the 5 minus 3. That also gives us 4 squared. And so, that's why our division property works. So, let's talk about the quotient. Well, I call it division property, quotient property, because quotient means division, right? So, our quotient property, let's move the cat. Our quotient property states that if we have the same base, so a to the m divided by a to the n, then that is the same as taking a to the m minus n. And again, we have to have that same base. And then we also have a power of a quotient, so very similar to the power of a product. So if we have a divided by b, that's our quotient, to the mth power, that would be the same as a to the m divided by b to the m. So we distribute it to both the numerator and the denominator. Alright, so example 5. We're going to simplify these. So I have the same base. The base is 2, so I'm going to do 2, and then 6 minus 2. So 2 to the 6 minus 2 would give us 2 to the 4th power. If it said evaluate, then we would do 2 to the 4th power, which is 16. Here I have my quotient, so power of a quotient, so I'm going to distribute the 3 to both of those, so we'd have 3 cubed over 5 cubed. And again, if it says to evaluate, then we would take 3 to the 3rd power and 5 to the 3rd power. So just read your directions in Math Excel to make sure that you do that correctly. Alright, so here we have a little bit more than just one. I have both m and n, but I want to make sure that I'm looking at just the same basis. So I'm going to work with my m's first. Now, I can do 2 minus 5, but that's going to give me a negative. And so the way I'm going to think about it is, wherever the exponent is bigger, that's where the base stays. So 5 is bigger than 2, so my m is going to stay on bottom. So I'm going to have m, and then I'm going to do 5 minus 2, which is 3. So I'm going to have m to the 3rd power. And then I'm going to look at my n's. Now, 4 is bigger than 3, which means n is going to be located in the numerator. And then 4 minus 3 is 1. And so you can either put the 1, you don't have to put the 1. Remember, 1's one of those invisible ones. Now that these are two different bases, this is my answer, because I can't do anything once they're different bases. Here we have multiple things going on. I have a quotient, but if you look here, I also have a product and a power of a power. So we've got a couple, like I said before, a couple things that will mix in as we use our rules. Again, just like we have before, because this is negative, I'm going to go ahead and flip this. And so I'm going to make this y to the 4th is going to come to the top, to the numerator, and 2x to the 6 is going to go into the denominator. And now I'm just going to think of the fact that I need to cube all of that. And so now I'm going to distribute this cube to everything. So y to the 4th cubed is going to be y, and I'm going to multiply. So 4 times 3 is 12. And then I'm going to do 2. Remember, there's that invisible 1 here. So 1 times 3 is 2 cubed. And then here we have x to the 6. So 6 times 3 is 18. So we have x to the 18th. And then your last step is that we would evaluate any integers. So our y to the 12th will stay, but our 2 cubed is going to become 8, because 2 times 2 times 2 is 8. and then we get x to the 18th. And then that is our final answer, completely simplified. So again, if it makes sense when you have the negative on the outside, I like to flip first just because then I'm not having to worry about multiplying by a negative. But you could multiply the negative all the way through and then flip at the end. That's your choice. All right, and then that is it for our division properties. And we'll talk about, real quick, how to use these rules for scientific notation.